Pretty sure all your work is Poisson. Now, when we get to the next chapter next week, a lot of people get this confused with exponential. And I want to make sure you know the difference. Poisson is an interval of time or space. It's the number of occurrence over an interval of time or space. For example, you're working at a toll booth, let's say like a turnpike, and you say, what's the probability that 5 cars will come to my booth in the next half hour? That's Poisson, because it's the number of cars over a period of time, correct? But if I set the question, when we get to the next chapter, we'll say, what's the probability that I get a 10-minute break between the next 2 cars? That's time over occurrences, between occurrences. That's exponential, that we're going to in the next chapter. I can't tell you how many people get those confused. They'll read the question and they'll think it's exponential when really it's Poisson or vice versa. So 1 is the number of occurrences over space or time or something. And Poisson's always discrete data. So think about how many cars could go by that booth. 1, 2, 3. There's no way 2.5 cars could go by my booth in a half hour's time, right? So that's how you know it's Poisson, because it's the data you would collect. If you're measuring how many cars over intervals of time, it would be 1, 2, or 3. Hey, how much time between cars? Well, between this car that just went and the next car is coming up, there was a whole 30 seconds. There could have been 42 seconds. There could have been 2.5 minutes. It could have been 2.2 minutes. And that is continuous data, and that's why that's exponential. 1 is the time between occurrences, 1 is occurrences during an interval of time or space. So, here's an example. How many knot holes in 14 linear feet of pine wood? It's the occurrences over a space. 14, how many knot holes in this 14 feet of pine wood? The number of vehicles arriving at a toll booth in an hour. There we go. Same example I used. Here's the formula. You're going to learn Excel, the back of the book, and the formula to solve these, whichever you choose to use. That's up to you. The formula, here's the deal with this. E is always 2.71828, just like pi is always 4.2. E is always 2.71828. It's in stone. So if there's an E in any of these formulas like this one, it's always 2.71828, whatever. There's more digits than that, by the way. The mu symbol is the mean number of occurrences that you read in the story. We usually have 5 cars a half hour go by this booth. That's the mean, or the expected, or the mean. We average 5 cars an hour going by this booth, or this ticket cashier usually has 10 customers an hour before a movie starts, or something like that. It's the average amount that you'll be given in the story. The X is what you're being asked to find the probability of. So that's all the variables. What you're being asked is the X, what the mean amount you've been told in the story is the mu, and the E is always 2.7182. Now, in the back of the book, we're going to page, gotta find it here, 661. So we're going past binomial, back a little farther. Here's mine. Whoops, right here. Let me get this other book out here. Which page? 661. Notice the P. If the story said, not the mu. And the story says, we usually have 2.1 customers an hour. You've got to find 2.1. There's pages. The numbers keep getting bigger. Oh, here's 2.1. And you're being asked, what's the probability that we usually have 2.1, that we only have 2 in the next hour? There it is. Okay? So now, you got that, you got the book, and we're going to do Excel in a minute, but I want to get into the story of the example. You ready? Patients arrive at this emergency room at this Mercy Hospital at an average rate of 6 per hour on weekend evenings. Which variable were you just given? That's right, the mu. This is the average right there. But be careful, because the mean has to match the question. And this happens often. What's the probability we'll have 4 arrivals in 30 minutes on a weekend evening? Okay, what's X? How many are you being asked about? 4. What's mu? Not 6.
Do you convert into minutes?
That's right. No. You ready?
It's like
Because the question's about 30 minutes, you got to take the mean and cut it into 30 minutes to equal the question. If this question is about 15 minutes, you got to change that hourly mean to a 15-minute mean. If it's 6 per hour, how many per 30 minutes? 3. How many per 15 minutes? 1.5. You get it? Whatever the amount is for the interval, if it says we usually have 10 knot holes per 14 feet of wood, what's the probability this next 14 feet of wood has 9 knot holes? They're both 14, so you can use 10 and 9. But if it said, what's the probability we're going to have 6 knot holes in this 7-foot piece of wood, what was the mean? What was the mean for the 14 feet? No one remembers? 12. 14, I don't remember. 14. So the 7-foot, what would be the mean? If it's 14 for the 14 feet, 7 foot would be how many? 7, because it's half the size of the wood. If the mean is usually 14 knot holes, if 14 feet, 7 feet would be 7 knot holes, but we're asked about the probability of 6. Mu would be the 7, X would be the 6. You've got to convert the mean to the same interval of time or space as the question. So, we're being asked the probability of 4.5 hours, when usually we have 3.5 hours, because we took 6 per hour, turned it into a half hour. 3. The formula would be the mean, which is the mu, to the power of what we're being asked about, 4, times e to the power of the negative mu. So 3 per half hour is our mean, put it to a negative exponent to our e, divided by what we're being asked about, factorial. 4 times 3 times 2 times 1 would be the denominator in this case. We do all the math on that, we get 16.8%. There's a 16.8% if we usually get 3.5 hours in this hospital, that the next half hour we'll get 4, about a 16.8% chance that we'll get 1 more than the usual amount we usually get. Okay? What if I would have said, though, what we usually get 3.5 hours, what's the probability we're going to get 4 or less? You got to do this calculation for 4, for 3, for 2, for 1, for 0, add them all up. Anybody hear that? Crazy, huh?
Excel.
And what did I say, 4 or more, or did I say 4 or less?
4 or less.
4 or less, that's right. Okay. Whoops, hang on, where's the book now? We're going to do the same problem here. We usually get 3.5 hours. What's the probability we're going to get 4 in the next half hour? So we go here, we're looking for 3. Always the big numbers, the dark numbers across the top of each one of these rows are the mu. So we're looking for the mu, or mean, for a half hour of 3. Going all the way across right there. If we're a number bigger than 3, I have to go to the next page. They get bigger and bigger each page. Now I'm being asked about what's the probability that we'll have 4 in the next half hour. 1. There it is. Same answer. But boy, this is going to be easier. What's the probability we'll have 4 or less? You add that. All together, you found the probability for 4 or less. What's the probability we'll have more than 4? Now you could go all out of these, or just add these and subtract from 100%, and you found the probability of more than 4. The opposite of 4 or less. Or you could add all these. And really, there's a number for 13, 14, 15. This really should not add up to 100%. I don't know if it does or not. It's just that the numbers are so small for everything past this, because We could get, hell, a building just fell over. We could have 14, 15, 16 patients in the next half hour. It's possible, right? This is an example of infinite. But the probability is so small, there's no reason to put all the rest of them on here. They're so minute. They're so close to zero, you can kind of call them zero. In reality, though, there is a probability. It's just so close to zero. When usually we only get 3.5 hours. Now, Excel. Here we go. Let's see. The command is Poisson. That easy. Equals P-O-I, and then I stop and just double click right here on the word Poisson. It says the first number should be X, whatever you're trying to find the probability of. In this case, we're trying to find the probability of 4 patients arriving in the next half hour. So I'm going to put a 4 there. Whoops, there we go. Comma. The next one is the mean. However many patients that you usually would get in a half hour's time, which would be 3, because it said 6 per hour. Now the last one, you put a 0 if you're trying to find the probability of just 4. You'd put a 1 if you're trying to find the probability of 4 or less. All right? So I'm just going to throw a 0 in. And if this is right, we should get, what was it, 16.8 or something? 16.8% chance of 4 coming in the door when usually we get 3 in that half hour time. All right. I want to do.
Can I ask a question? Everything you said, and I want to underscore this. When you put 0, it's always whoever number you put in.
The exact. You're trying to find the probability then of just that first number only. But if you put a 1,
Oh, I'm sorry, 1. That's what I said, 1. You put a 1 in there.
which I was about to.
Always whatever. It's all the numbers. It's inclusive of the number and all the numbers before.
That's right. And the 1 will only give you the probability of some number or less.
Or less.
There's no way of doing or more unless you put the 1 minus in front. If you do the opposite of, so let's try this. Ready? Tell me what numbers you would use. Right now we're at 430. Usually we have 6 an hour, 3.5 hours. What's the probability that we're going to have 3 or less in the next half hour? What will be the first number?
3.
What would be the second number? What would be the third number? You've got it. 331 represents 3 or less. Here we go. What would be the numbers if usually everything's the same? What's the probability we're going to have less than 4 in the next half hour? What's the first number? 3. That's right. 3 again. I tried to trick you, and it worked.
Yeah, exactly.
3 is the first number, 3 is the second number, 1. I just stated it a different way. Instead of saying 3 or less, I said less than 4, which is 3 or less. You've got to watch those words. Believe me, if you look at the homework questions in the back, right by this part of the chapter, you'll see that they're stating it all these different ways that I'm trying to get you to hear right now. Everything's the same, but I want you to tell me what the probability is that we're going to have more than 4 in the next half hour. More than 4 in the next half hour. What's the first number? Nope.
No, less than
The
4.
first number,
No, it's more than 4.
more than 4, the first number, which is now a 4, is going to be what number?
5.
More than 4.
More than 4?
More than 4. Remember, any question that ever asks for more, in Excel, you got to put the opposite of the question. 4. More than 4 would be 5 or more. The opposite would be 4 or less. The first digit's a 4. The next digit's still a 3. The next digit is a 1.